Hello everyone, this is Mr. Aguilar here. We're talking about continuous functions today. Please copy down the following problems or the following notes. Continuous function is a function whose line that doesn't break. It's a line with not distinct points. Another way to think about it is if you can draw the graph without picking up your pencil, it is considered continuous. The line does not have distinct points on the graph. So it looks like a line, it looks like a shape, it looks like a circle. And that's what you want to be able to take it across. One way that we could say here is we can draw the line without lifting your pencil. In the figure to the right, we can draw this line continuously, meaning without picking up our pencil, through the whole point, okay? And that's what you guys got to be able to take from here, okay? The way that we do continuous functions with reflecting domain and range is done a little bit differently. For discrete, we give a list of points and we're able to write it. And we're going to do a problem example later. For domain, it is written a little bit differently. The domain value is going to be the left number is less than or equal to x, because that represents domain, is less than or equal to the right number. And that might not make sense right now, but we'll get into that. For the range is done very similar. Our range will be the bottom number less than or equal to y, because range represents y values, is less than or equal to top number. And that might not make sense right now, but we will cover it and it will make sense to you guys in a little bit. I'm going to rewrite these down the next page for you. The two that we're going to get here, we're going to find out the domain and range. One thing that I want you guys to be able to identify is that we're doing the box method. The box method will help you clearly identify what numbers you will use for the domain and range for a continuous graph. Both lines that we have down below can be drawn just by graphing, just by drawing the line without picking up your pencil. The box method is place the smallest box around your graph or figure. Then you want to determine where the box intersects the x and y axis. Okay, and we're going to try to figure this out. Our domain for the first one, like how we wanted to rewrite it, we write it with the D. Some number is less than or equal to x, which is less than or equal to some other number. Our range is done very similarly. Let me kind of erase this for you guys a little bit. Our range will be some y value less than or equal to y, which is less than or equal to another value. We call these constraints. We want to limit the domain and range to certain values. Because it's continuous, we have it ranged over a certain set of values. So it's between two numbers. The first thing that I want you guys to be able to do here is create the box. And this is using the box method. So I'm trying to put the box in the smallest form I can. And let's do this again one more time. So that's the smallest box I can come with that will fit my graph. What you want to be able to notice here is looking at the box now, seeing where it crosses on our x-axis. Those are our 2 points that it crosses at. For our y, it will be our lowest point on my y-axis and the tallest point on my y-axis. These will represent your domain and range. The left point for this will be -4. The farthest right will be 4. So those are what's going to correspond to our domain and range. We always work left and right point. The bottom one will be from -3 to 2. So -3 is our bottom number, 2 is our top number. And that's all you got to be able to do to give me the domain and range for a continuous graph. Okay, here are the ones that we're getting here. I'm going to kind of draw this out just so you can see the difference in what we're doing. Okay, I'm adding on to this figure. What I want to be able to do now is graph my, or box, put a box around my line. Our box is locked in. Again, we can do the same type of process. The farthest left point of my x is going to be -1. Farthest right will be 1. Top will be 3. The bottom will be -2. Okay, and we want to correspond them just as we did before. Domain is -1 less than or equal to x, which is less than or equal to 1. Again, domain represents inputs, which also represents x values. Range, similar. -2 is less than y, which is less than or equal to 3. Okay, that's our domain and range. That's all you got to be able to do. Okay, so practice those and try those out. Okay, look at how I got those values. I'm not looking at the line anymore. Once I put the box around, I'm looking at where the box crosses the x and y intercept. So keep that in mind. Here we go. The next one we're going to do over here is a practice problem. Okay, we know it to be continuous, and you want to be able to give me the domain and range of this function, okay, this value. So the first step we got to be able to do, put a box around our function. Even though it kind of is a little bit light, we'll just assume that it stops there. The next thing we want to be able to do is find my left and right point that it crosses up my line. The top and bottom, boom, boom. The farthest left it goes is -2. Farthest right it goes is 2 for my value of x. For the y value, the lowest it gets to is -2. Highest it gets to is 3. In my correction, this should have been a 3, right, for my value. This should have been 3 for my x. Okay. We're going to go ahead and write the domain, -2, which corresponds to my value there, less than or equal to y, or x, sorry, which is less than or equal to 3, which represents that value. We're going to do our y's. -2 is less than or equal to y. My -2 will represent on that bottom of that 2, less than or equal to 3, which will represent that top number above. So that's all you got to be able to do for the domain and range. This is called a composite interval or a reduced interval. We're looking at two values. We're looking at how it exists between -2 and 3, -2 and 3 for our x and y axis. So just keep that in mind. Let's try another problem out. And don't let these things get intimidating. This looks like a weird Z. It looks totally confusing. Never seen a line like that. Don't worry about it. We're going to try to do this. We're going to go ahead and create a box around it. That's always the first step, and it's going to help you guys out so much. Okay, box, boom. I now want to look at my lines now. So farthest left point is -8 here for my x. Farthest right point is 7. Okay, we're going to go up on top. This is going to be 5. The bottom will be -1. Okay, so keep that in mind as we do these. The inequality we're now going to use is the following. We're going to go ahead and go back and go, our domain is -8, which is less than or equal to x, which is less than or equal to 7. It's a left and right point. The range, done very similar. Done very, very similar. Our range will be -1 is less than y, which is less than or equal to 5. Okay, representing the bottom and top. Okay, it is important that you guys keep those in the correct order. The left goes with the left side, the right goes with the right, the bottom goes with the left, or the bottom goes with the term on the left side for their y value. Top value goes with the y. Okay. Okay, looking at this one, we just have 2 more. We have this one and another practice problem. We're going to go ahead and box it up. Let's try it out. Box. Okay. Want to make it the smallest I possibly can. I'm going to redo that. So the smallest I possibly can would be here. Okay. Again, stop moving away from it. We're going to move away and get the box method. So there's going to be -2 to 8. So my domain will be from -2 less than or equal to x, which is less than or equal to 8. Again, domain is x values. Range, I'm looking at my lowest values, -3 to 4. So those are my intersections. -3 is less than or equal to y, which is less than or equal to 4. And I would love for you guys to pause it and to actually look at what I'm doing here and practice these problems and see what I'm getting right and wrong. And on the next couple ones, pause it and see if you can get them right. Okay, definitely want to try these out. We're going to continue. Okay, this is a problem I want to go over. So we're going to look at two different types of functions. Okay, we talked about these before, what it means to be continuous and discrete. We're going to classify them before we even do them. The first part of these is being able to say that the first one with dots is discrete. Discrete means dots. Discrete. And then we have the one to the right, which it looks funny, but if I can draw it without picking up my pencil, it's continuous. Continuous. I hope I spelled that right, and I apologize if I got it wrong. Okay, we're going to go ahead and do these. For discrete values, it's done a little bit differently, remember? We're given a set of points, so we're going to be able to write those out. The best way to do this, like I told you guys before, is just list the points. We're going to go back and give me -3, -2, -1, 0, 0, 2, 1, -2, and 3, 1. And we know that we can write them as a list of domain and range values just by giving me the coordinate points for those, right? We're going to give you just the first value because the first value represents my x. So let's go ahead and do that. -3, -1, 0, 1, and 3. Those are our domain values. The range values are done the same way, except we just use the ones that are to the right of it. X and Y coordinate points gives us the ones that are right next to them. The right are our Y, are our range values, right? So we're going to go lowest value, -2, -2. You do not need to repeat yourself, but for those that are just trying to get the hang of it, let's go ahead and write them all. 1 and 2. And then we're done. That's how we do discrete. We can list everything. Discrete means dots. We can list all the points, okay? Now for continuous, it's done slightly different, right? We looked at a different type, and what we had to be able to do was the box method around here. So I'm going to get here, get the box around it, boom, okay? Our box is around the whole function, and we're okay with that. We can definitely do that, okay? We're going to look at our farthest left point, our farthest right, our domain. Since it's continuous is written differently, we're going to go -5 is less than or equal to x, which is less than or equal to 5, okay? -5 here, 5 over here, so that's where we're getting our values. Lowest one right here for our y, or our range, will be -2, 2, 2. So we're going to write our range as our lowest number. -2 is less than or equal to y, less than or equal to 2. Okay. So look at how differently the domain and range are written for continuous and discrete functions. So keep that in mind as you guys do today's homework. We have not discussed over what a function is, so keep that in mind. I hope you guys are getting this down. Please ask me any questions if you need further help. You guys have a fantastic day. Take care. Bye-bye.